Now we kind of want to switch gears. So now that we've talked about pretty much all the ways to write electron configurations, there's one more way I'll talk about at the end, and that's for our ions, our cations and our anions. But now that we've kind of talked about electron configurations and that kind of trend based on the layout of the periodic table, I want to introduce a couple of more trends based on the periodic table. So remember we said that it's called the periodic table because there's periodicity. So the regular periodic occurrence of properties. So because of the way the periodic table is laid out, I should expect certain properties to occur in a pattern. So the elements that are in the same group or column tend to have very similar properties. So the first property we want to talk about is metallic character. So it might be a little hard to see the coloring in the PowerPoint, but if you flip to your textbook to the periodic table, it'll be colored very similar. Okay? So one of the ways we can talk about the periodic table is its metallic color character. So we have metals, metalloids, and nonmetals. We have 3 different types. So over here are the metals. Right here, which is hard to see, is your metalloids and then your nonmetals. So as you go from left to right, you become less metallic, and as you go from top to bottom, you become more metallic. But let's talk about these 3 individuals. So we have metals, nonmetals, and metalloids. I'm actually going to go to the previous slide just so I have more room to write. So first let's talk about properties of metals. So metals are going to be solids at room temp. The only exception is what? Mercury. So solids at room temp. Metals conduct heat and electricity. That's why we usually use them when in like piping and wires and stuff. They are shiny and malleable. So shiny, think about like a coat of armor from the knights back in the day, like in King Arthur and the Round Table. So it's really shiny, their coat of armor. And malleable. So malleable means it can be shaped. So if it wasn't malleable, I couldn't take and hammer it into the shapes to make a helmet or a breastplate or shoulder plates or all those things. So nice and shiny, but I could beat it up so that I could shape it into whatever I want it to be in. Metals are ductile. So ductile means that they can be drawn or pulled. Keep hitting the buttons at the bottom, into wires. So this is just a property of the fact that I can take some metal and I can actually pull it into a nice wire shape. Because it's so malleable, it's malleable enough actually that I can actually make it into wires. And so that's why a lot of my wires, like copper wire or those kind of things, are made out of metals. Now, one of the properties of metals that we're going to talk about a lot, and remember we talked about this a little bit when we talked about ions. The big thing with metals is that they like to lose electrons. Metals are going to lose electrons, and if you lose an electron, that means you form cations. That's going to be one of our biggest trends. So when we're talking about these guys on this side, like to have a positive charge. They want to be cations, and that includes my transition metals here, which we'll talk about those in a second, and the names of them. So if you don't know it's a transition metal yet, it's okay. I'll tell you in the next slide. All right, so these guys on the left, the metals, want to become cations. All right, let's talk about nonmetals. Nonmetals are found in all 3 states. Where metals are mainly found as solids, nonmetals, some are liquids, some are gases, and some are solids. Now, metals are good conductors of heat and electricity. Nonmetals, these guys are poor conductors of heat and electricity. These guys are poor conductors. And for those nonmetals that are solids, these guys are going to be brittle. So if they are a solid, those solids are going to be brittle. And then nonmetals, these guys like to gain electrons, which means they're going to form anions. So left side of the periodic table, where my metals are, they're going to be positive. This side of the periodic table is going to have a negative charge because they're going to be anions. So now we want to talk about, you see this bolded line. This bolded line is what separates my metals and my nonmetals, and those on this bolded line are what are called metalloids. Okay, so metalloids would be my boron, silicon, germanium, arsenic. We'll just keep going all the way down. All of those guys, those are the ones so that you can kind of see. Everybody on this side are going to be my metals. Everybody on that side is my nonmetals. The exception here is hydrogen. He's a nonmetal. So that should kind of help you see the coloring. Everybody else here, metals, nonmetals, and then the red guys are my metalloids. So what are metalloids? So metalloids, depending on which one we're talking about, might be more metallic or it might be more non-metallic. So it has a mixture of properties. So it's kind of like a hybrid, okay? So some lean one way more than the other, but they kind of have a mixture of some properties of one, some properties of the other. So because they're a mixture, if metals are good conductors, nonmetals are poor conductors, metalloids are going to be semiconductors. So these guys, their big kind of claim to fame is that they are semiconductors. So good conductors, poor conductors, semiconductors. All right, so that's one way that I can look at the periodic table and talk about a trend. But another way that I can talk about it is where it's at. So I kind of hinted that these were called transition metals. So the different columns or groupings, you can even see some here, have names. So now we want to go through and talk about the names of the different columns or sections of the periodic table.